Hi everyone, today we are going to build an artificial neural network or ANN from scratch using Python and NumPy. For the dataset, I will use load arrays, which is a built-in dataset from scikit-learn. This means we don't manually download a CSV file, but you can download it if you want, and you can use the CSV file as is it. So also we simply call the dataset loader and Python returns the data directly. So the official scikit-learn documentation describe arrays a classic multi-class classification dataset with 150 samples and 4 features and 3 classes. The idea of ANN is that we pass the input features through layers of neurons. Each neuron computes a weighted sum, adds a bias, then apply an activation function. During training, the network compares its prediction with the true labels, computes the error, and updates its weight using backpropagation and gradient descent. So in this notebook, we will use scikit-learn only for loading the array dataset. And the ANN model itself will be written manually with NumPy. So we need to import some libraries. We will import NumPy as NP, and we will import pandas as PD, and we will import also matplot library dot pyplot as plt, and finally I need to import sklearn dot datasets import from import load array. After that I need to load the arrays dataset, and this is a built-in scikit-learn dataset, so arrays will equal load array. After that, I need to print the full description of the dataset, and it will explain what the dataset is and how many samples it contains and how many features it has and what the classes represent. So print and it is description. So we have 150 samples and we have 3 classes, and each class we have 50. And we have these attributes, the sepal length and the sepal width, and petal length and petal width. And we have 3 classes and the minimum and maximum and means for each class. So after that, we need to print the keys of the dataset object. This shows the main parts returned by the loader, such as the feature matrix, target vector, and feature names, and target names, and description. So we will print arrays dot keys. So we have data, target, and frame, target name, description, feature name, file name, and data model. So we need to print. We need to show the names of the input features and the classes and the class names. So print feature Print and print. Here is feature names. And we need to print also \n target names. And we need to print target names. So and here is the four features corresponding to petal and petal measurements, and the target names correspond to the three flower pieces. So the official documentation describe areas as having four features and three classes, as we see here. We need to print data shape. Print arrays and data dot shape. We need to print target shape and arrays target dot shape. So we inspect the shapes of the data and target according to what we give us. We have 150 samples and 4 features, so the data shape is 150 and 4, and for the target shape 150. Now we need to convert the feature matrix into a pandas data frame, so the feature will equal pd dot data frame. Here is data and columns for feature names. So, and this makes the dataset easier to inspect in a table format because each column receives its real feature name. So we need to show the structure of the feature table. We can see the number of rows and the number of columns and the data type of each column by the feature.info. We can see here. We need to look at the target labels. These are stored as number and the target names tell us which flower class each number represented. So we would need to print first target values, and we will print. It is target 10, and we will print also \n target names, and it is target name. So we have this value 0, and this 0, it's Setosa. And for this 0, and for this 1, and for this 2. Now we need to store the input feature in X and the labels in Y. And this is the standard machine learning notation. So X will equal array data and Y array target. And we will print the shape for each of them. So for our A and N, we convert the class labels into one hot encode. So we need two num classes equal len and b unique y and number, and we need y one hot equal mb dot I mb num class for y. So since arrays has three classes, each label become a vector of length 3. This is useful because our output layer will use softmax and produce probability for all three classes. And we can see the print here. Print number of classes sum of classes, and we will print first 5 or 1 hot encode label, and we want to see the output. So each one of each class, he has three values. The first value for the first class, and the second class, and the third class. After that, we need to build split the data into training and testing sets manually using NumPy, and we also split both the original class labels and the one hot labels because we need one hot labels during A and N training and normal labels during evaluation. So we need df define a function train test let NumPy, and it will take x and y and test size and random or seed, because we didn't need to change the variable always. And we need to pass also y1 hot. Okay, after that we need to make a random generation and b dot random dot default r&d seed, and after that we need an samples, the count of all samples. We will take x dot shape for the first value, and we will take indices will equal mb dot arrange for ensemble, and we need to make a shuffle exactly, and we need this count equal and this sample multiply with n samples, and we need test indices. We will take the last, and for training we will take the first, and xtrain will equal xtrain indices, and xtest will take test indices, and for ytrain will take train indices, and ytest will take test indices, and for y1 hot train Or okay, it will take test and train indices also. And we will return x train and x test and y train and y test and y1 hot train and y1 hot test. So that we need okay to make a training, and we will pass x and y1 hot and test size 0.2 and seed 42, and we need to print x train shape and x test shape and y train shape and y test shape. Okay, as we see here. After that, we need to make a normalization, the input feature manually, and this helps the ANN train more smoothly because feature one very different scale can make optimization harder. So we need to compute the mean and standard deviation from the training set only. Then we will use them for both training and test dataset. So we need to calculate train mean will equal x train dot mean for axis 0 and train std will equal x train dot std, and we will count. We will need to train std will equal b dot where for return std if it's equal 0 it will return 1, else it will take train std and x train we need it and x test exactly. We need to print now first 3 rows of random size of train of or training data, and we will print the value and all of the data from 0 to 1. So we need to define activation functions. We will use ReLU in the hidden layer and softmax in the output layer. So ReLU helps introduce nonlinearity, and softmax converts the output scores into probabilities across the three classes. So we need to define ReLU, and we will pass Z, and it will return for us mp dot maximum between 0 and Z, and we need to define a softmax, but before softmax we need to define the ReLU derivative mp dot where and Z more 1, else return 0, but I need to change it to more easier. Z, if Z more than 0, return as type dot. And we need to define a softmax of Z and Z shifted will equal Z minus MB dot max z axis 1 and keep dimensions and exponential for value z equal mb dot exponential for z shifted, and we will return exponential values or z mb dot sum for exponential z and axis 1, and we will keep the dimension also. So we need in this cell, we need a function to compute the cross entropy loss. Since this is a multi-class classification problem with softmax output, cross entropy is the appropriate loss function. So define the cross entropy loss, and we will pass y true for one hot and prediction probability, and epsilon will equal 1 minus e to the power minus 12, and y prediction should be will equal mb dot glib for y predict prob and epsilon and 1 minus epsilon. Y predict probability and y true exactly. So we need to initialize the a and n parameters. So we have W1 and B1 belong to the first layer, and W2 and B2 belongs to output layer. We use small random values for weighted and zeros for bias. So we need to define initialization parameter, and we will pass input size and hidden size and output size and seed, because we didn't need to change the data between one to another. 42, and we need to make R and G. And for W1, R and G dot normal 0.1 and 5 equal input size and hidden size, and B1 the same but zeros, because we need 1 and exactly, and W2 the same of W1 but not for the hidden, for the output, and between hidden layer and output layer. So we need to return W1 and B1 and W2 and B2. So we need to change these to 2. I forget to change it to. After that, we need a function to perform the forward propagation. First, we need to compute the hidden layer linear combination and apply values. So we need to define a function forward propagation, and we will pass X and W1 and P1 and W2 and P2. And we need to calculate Z1 equal X multiply with W1 plus P1. And for activation function, we need to calculate the value for Z1. After that, we need to compute also the output layer linear combination and apply softmax to get the classes probabilities. So we have Z2 also will equal A1 multiply with W2 plus P2. And we need to apply the softmax for Z2. And we will return Z1 and A1 and Z2 and A2. We need a function also to perform back propagation. It computes the gradient of the loss respect to all weighted and biases. So we need to define back propagation. We will pass X and Y through one hot and Z1 and A1 and Z2 and A2 and W2. So we need to calculate the n samples as we did it before. We will take the shape of 0 for X and we need to make dz2 equal A2 minus Y through one hot and dW2 the multiplication between these A1 transpose multiply with derivative of Z2 divided by n sample and P2 for the bias and n sample here. Okay, should be n samples, but it's okay, the same. And D for A1 will equal dz2 multiplied with W2 transpose and dz1 equal dA1 multiplied with ReLU derivative for Z1 and dW1 will equal X transpose multiplied with dz1 divided by n sample and dB1 dot MB dot sum for dz1 axis 0 keep divided by n dimension and we will return dW1 and dW and dB1 and dW2 and dB2. Also, we need a function updates the A and N parameter using gradient descent. Each parameter moves in the direction that reduces the loss. So we need to define a new function, update parameters, and we will pass W1 and B1 and W2 and B2 and dW1 and dB1 and dW2 and dB2 and learning rate. So W1 will minus equal learning rate multiply with dw1 and b1 minus equal learning rate multiply with dp1 and w2 will equal the same thing, and we will return w1 and b1 and w2 and b2 exactly. So we need to make a full and training function. In each epoch, we perform a forward propagation, compute the loss and return propagation, and update the parameters, and save the loss for later visualization. So we need to define a new function, train n, and we will pass x and y one hot and input size and hidden size and output size and learning rate will equal 0.01 and x will equal 1000 and seed will equal 42 and w1 we need to initialize parameters. We need to initialize the parameter here. Initialize parameters and we will pass input size and hidden size and output size and seed equal seed and for it we need one variable for loss history because we need to save it. So we need first to calculate the forward propagation and after that we need to calculate the loss will equal cross entropy loss and we will pass y1 hot and a2 and loss history to append loss and we need to calculate the back propagation now and we will pass the parameter and z1 and a1 and z2 and a2 and w2. After that, we need to update the parameter. Update parameters. And we will pass all of these. And we need to save the loss for list history of ebook last one. Okay. Or equal 0. Ebook plus 1 for digit. And loss will equal 160 float. Exactly. So now we need to choose the network size. So the input size, the number of features, which is 4, so input size will equal x dot train dot shape for 1 and for hidden size we will use 10 and output size we will use number of classes. Then we need to train the model. So we need to pass the train and y1 hot train and input size will equal input size and hidden size will equal hidden size and output size will equal output size and x will equal 1000 and learning rate 0.01 and heat 42 and we can start training. Has no attribute zeros, yes, so we need to use MB, not R and G. Only I put wrong numbers really. MB. We need to fix this also. We need to rerun it. And we need to rerun this one also. So after training, we need to predict. So we need to define a new function, predict ANN, and we will pass x and w1 and b1 and w2 and b2. And we make a forward propagation, exactly. And we will return. So it runs forward the propagation and then it chooses the class with the highest softmax probability. So we need to apply the trained and to the test and get the predicted class label. So y predict will equal predict and we need to pass x test and w1 and b1 and w2 and b2. We need to calculate the accuracy. So accuracy y true and y predict, and we will calculate the mean between y true and y predict, and we need to take the accuracy equal accuracy for y test and y predict, and we will print test accuracy. 93%. If we need to calculate the confusion matrix, you can calculate it, but I need also to make a plot how the training loss change across epochs. if the ANN is learning correctly, so the loss should generally decreasing, so we need to plot dot figure, and we will pass figure size, and we need to plot the loss history. And we need X label and Y label and title, ANN, then loss, and zero, and show. We need to show it. As we see the training decrease, the loss generally decrease, so the accuracy it's good and the learning for ANN it passed correctly. So thank you, and you can do or you can change the data set, you can change anything, and you can add some coded, for example, the confusion matrix, and you can make a test for data, for on data. Thank you. See you in the next lecture.